Hello everyone, thank you for signing in. I'm Mr. Matt and this is Dr. Tot. You want a cookie, Dr. Tot? Yes. And welcome to Algebra 2. We're going to continue our discussion today with factoring. In streams 1 and 2, we concentrated a lot on when a is equal to 1. We're going to review the standard form of a quadratic, how to identify the coefficients based on those leading variables, a, b, and c. And also the rules pertaining to when a is equal to 1, the simpler version of factoring. But I really wanted to hit hard on the more complex, the more complicated form of factoring when a is not equal to 1. Remember, when a is equal to 1, when we don't have a leading, when the leading coefficient is 1, and oftentimes we colloquially or commonly refer to it as just not having a leading coefficient, because whenever the leading coefficient is 1, we don't have to write it. 1 times anything is that same something. So in math, when we have a leading coefficient of 1, like x, it's really 1x, and technically it's really 1x to the 1 power. All of those things are implied, but we don't have to write it because the coefficient of 1 and the exponent of 1 are inconsequential to the value. It doesn't change it at all. But we need to know that it's there. When a is equal to 1, we factor by finding two factors of c that add together to get b. With a not being equal to 1, it makes it a little bit more complex. There's two extra steps that we have to take. First, we're no longer considering the factors of c to get the factors of c to get b, two factors or two values that multiply together to get c, but add together to get b. Now, when a is not equal to 1, we have to consider a times c. So it's the factors of the product of the leading coefficient and the constant value at the end that add together or subtract together to get the b value. Because there's a leading coefficient to the squared variable, when you split that variable up, you actually have to consider its own factors and then do a little manipulation, little massaging to make sure that those leading coefficients don't mess your ultimate answer up. Because remember, we have to be able to FOIL to get our original value back. FOILing is analogous to multiplication of binomial forms. Factoring is analogous to division, or you can think about them in parallel structure. So let me go ahead and share my screen with you. And just a reminder, this is a live session, so there's a little bit of a delay with the iPad, but I'll try and keep track of that. If you ever need me to scroll up or down, please let me know. And also, if you haven't already, if you find these videos helpful, please like the stream and subscribe to my channel. I appreciate it. Okay, so the overarching theme, like I said, factoring is like division, FOILing is like multiplication, and they're opposite operations of each other. You can use them to check your answer. Again, this is going to go very quick in the beginning because streams 1 and 2, if you're still a little hazy with when a is equal to 1, I really recommend looking at 1 and 2 because I want to spend a lot of time today on the more complicated form. The standard form of any quadratic is ax squared plus bx plus c is equal to 0. Where a, b, and c are, well, a and b are coefficients and c is a constant value. The general rule, the more simplified form of factoring, is when we consider two factors of c that add together to get b. So for example, I have x squared plus x minus 6 is equal to 0 here. So this is in the form of ax squared plus bx plus c is equal to 0. So technically a here is equal to 1, b here is also equal to 1, c is equal to -6. Remember, when there's not a leading coefficient or there's not a coefficient listed, it's implicitly 1. Don't make the mistake of confusing it to be 0. If it were 0, it would nullify the whole thing. 0 times anything, 0 times x squared, 0 times x, 0 times 6. All of those values would go to 0 because 0 times any value is 0. But now that we've identified the coefficients, we're looking for two factors of c that add together to get b. So the factors of c, well, c is equal to 6. So the factors of 6 are 1 and 6, 2 and 3. Here's a little hint. 6 is an easy factor to think about because there's only a limited number of divisors, or it has only a limited number of divisors. If we had a larger number like 2,400, that would have a lot of factor pairs. Here's a systematic way of making sure that you've considered all factors involved. If you start with 1 in the number, and then you're going to work upwards on the left-hand side. As you do, you'll see that you go down on the right-hand side. You'll get to a certain point towards the end, like we do here, but we just do it right away because there's so few factors of 6. But notice the last pair of factors are consecutive values, 2 and 3. There's no values, there's no integers at least, whole numbers. There's no whole numbers between 2 and 3. So I know that I've considered all factors of 6. If we were to get to the end, and let's say that we had like 6 and 8. Okay, so if we were talking about 6 and 8, so we're talking about the number 48, for example. All the way at the bottom, we would have factors 6 and 8. This is a really helpful system to abide by because if we have this condition at the end, the only whole number in between 6 and 8, I'm sorry, you can't see that. Let me scroll up. My apologies, my camera is in the way. But the only integers in between 6 and 8 is 7. 7 does not go, 48 is not divisible by 7. So after I exclude or eliminate the possibility of 7 being a factor itself, I know that I've exhausted the list of factors of 48. So this is just a really handy way of making sure that you've got all the factors considered. A lot of students kind of guess and check at it, like, oh, maybe 6 is it's divisible by 6, maybe it's divisible by 15, maybe it's divisible by 3. If you do that, you never know if you've skipped one or not. So this system is really helpful. So we're looking for two factors of c that add together to get b, which is 1. Notice that, and we need to multiply together to get a negative 6. So when the c value is negative, that means that the factors are going to have opposite signs because only a negative times a positive will give you another negative, will give you a negative result. If the c value is positive, that means that both factors are either negative or both factors are positive. Because a positive times a positive will give you a positive, a negative times a negative will give you a negative. And that's what I'm talking about is when you go through the process of foiling back to get your original answer to check your process. So notice that, where did my 3 go? So 2 times 3 will give me a 6, and if one of them is negative, will give me a negative 6. The sign needs to take the larger value. The larger factor takes the sign of the b value when you have opposite signs, because the value with the higher magnitude needs to overtake the value with the smaller magnitude and remain that sign. So I want it to be positive 1. So I'm going to write out my parentheses. I'm going to assign my x to the first positions. So I have x and x. And now I need a negative 6. I need to multiply together to get a negative 6, add together to get a positive 1. So I'm going to have plus 3 and minus 2. Because when I FOIL out, remember foiling is first times first, outer times outer, inner times inner, last times last. When I FOIL out, I'm going to get first times first is x times x, Outer times outer is x times negative 2. Inner times inner is 3 times x. Last times last is 3 times negative 2. X times x is x squared. Negative 2 times x is negative 2x. 3 times x is 3x. And 3 times negative 2 is a negative 6. Notice that negative 2 plus negative 2x plus 3x is going to give you a positive x. So after foiling, we end up with exactly the same thing that we started with. And that's a check that you did the right process. So when a is equal to 1, it's relatively straightforward. You're looking for two factors of c that add together to get b. If there's any questions, then please let me know. You can comment in the live chat function, or you can drop a comment below. But now let's talk about when a is not equal to 1. So when a is not equal to 1, you need to write out two sets of parentheses and break the first squared variable into two variables raised to the first power in the left position of each parentheses. The coefficients of these values are factors of the a value that the factors in the right position can be evenly divided by. Look for two factors of a times c that add together to get the b value, and distribute the factors in the right position of each set of parentheses, and adjust the factors to work with the coefficients of the a value distributed in the left positions. Use foiling to check your factoring process. So there's two different values I'm going to consider the factors of. First of all, I have a is equal to 8. And then I need to look at a times c. That's the same thing as 8 times 3. That's 24. So the factors of a are 1 and 8, 2 and 4. Notice that the only number in between 2 and 4 is 3, and 8 is not divisible by 3, so I have exhausted the list of the factors of 8. A times c is 24. Start with 1 in the number, 1 and 24, 2 and 12. I'm sorry, I had to cough there. We have 1 and 24, 2 and 12, 3 and 8, 4 and 6. Notice how we go up in a consecutive fashion on the left, so there's no values in between them. And then also we end with near consecutive values at the bottom. The only number in between 4 and 6 is 5, and 24 is not divisible by 5, so I know I have all the factors here. Excuse me. So I'm going to split this guy into my parentheses. And now I need to distribute that 8x squared into the first position. I need to do that, though, considering the factors of a times c. So first I'm going to look at a times c. I need two factors in a times c that add together to get 10. So notice that, and then also look at this. This is a really good example because notice that 2 and 12 and 4 and 6 could both possibly work because positive 12 and negative 2 give me a positive 10. Positive 4 and a positive 6 give me a positive 10. However, look at this c value. The c value is positive. That means that both factors have to be positive or both factors have to be negative. So we cannot use 2 and 12. We have to go with 4 and 6 because that's the only way to use two positive values and to get a b value of 10. So I'm going to put 4 and 6 down in the right position. Notice that 2 and 4, the factors 2 and 4 are factors of 4 and 6. So they work with these values. If they work with the values, that's what I'm looking for because I have to assign this 8x squared into the first positions. So I'm going to do that, remember with foiling, excuse me one second. I'm so sorry. I've been talking for like 4 hours, so I'm starting to get my throat's starting to complain a little bit. So we need to split that 8x squared into the first left-hand positions, and I need them to work with the inner and outer forms of the foiling process. So the outer is going to be multiplied with each other to produce that central x value, and the inner positions are going to be multiplied by each other. So I need to make sure that I match up the values that are divisible, that work together. So I'm going to match 4 with 4, so I'm going to put 4x here. Actually, let me do another color. I'm going to put 4x here, and I'm going to put 2x here, because 6 is divisible by 2, and 4 is divisible by 4. 4 would not go into 6 a whole amount of times, right? 6 divided by 4 is 1.5. So I want the result, the quotients, as much as possible to be whole values. Now, because we have this added interaction of these leading coefficients 2 and 4, I need to adjust the corresponding values that will be affected by them by those values. So I'm going to divide the coefficients in the right position. The 4, I'm going to divide it by the 4 that it's going to be multiplied by, and then I'm going to take the 6 and divide it by the 2 that it would ultimately be multiplied by. I need both of them to be positive, so this is going to end up being 2x plus 1 times 4x plus 3. Now if we FOIL, we have to be able to get this back, the original problem back. So first times first, that's going to be 2x times 4x. Outer times outer is going to be 2x times 3. Inner times inner is going to be 1 times 4x. And last times last is going to be 1 times 3. 2x times 4x is 8x squared. 2x times 3 is 6x. 1 times 4x is 4x. And 1 times 3 is 3. 6x plus 4x is 10x. So notice we get back exactly what we started with. If there are any questions, then please let me know. We're going to spend the rest of the session practicing these types of problems. So I'm going to give you 4 minutes. Please look at this question. 3x squared minus 17x plus 10 is equal to 0. I'll keep track of the time in the upper right-hand corner and update it per minute. Okay, so looking at this guy, we have 3x squared minus 17x plus 10 is equal to 0. So a is equal to 3. 3 is prime, so its only factors are 1 in itself, 1 and 3. A times c, that's going to be equal to 3 times 10, which is 30. That's going to be 1 and 30, 2 and 15, 3 and 10, 5 and 6. Notice that 5 and 6 are consecutive, so we know that we have all of the factors there. And we need to add together to get negative 17, multiply together to get positive, positive 30. So we have negative 17, negative 2, and negative 15. So I'm going to write out my parentheses. Now we only have two factors to consider for a, so that makes it a little bit easier. We know that one has to be x and the other has to be 3x. And now we're using the AC factors of 2 and 15. 15 is divisible by 3, and every number is divisible by 1. So I'm going to put the 15 to associate with the 3, and I'm going to put the 2 to associate with the 1. Remember, though, that we need to adjust this to make sure that it works. So the 15 now has an added scalar factor of 3, so I need to divide 15 by 3, and technically I would have to divide the 2 by 1, or by its coefficient that it's going to be affected by, but the 1 doesn't do anything, so really it doesn't matter there. We need both of these values to be negative because we need a negative 17. 15 divided by 3 is 5, so this is going to turn into x minus 5 times 3x minus 2. And you could FOIL here to check. First times first, x times 3x, outer times outer, x times negative 2, inner times inner, negative 5 times 3x, last times last, negative 5 times negative 2. X times 3x is going to be 3x squared. X times negative 2 is a negative 2x. Negative 5 times 3x is a negative 15x. And negative 5 times negative 2 is a positive 10. Negative 2 minus 15x, negative 2x minus 15x, you could look at that using leave, change, change. Leave this sign alone, change the operator, change the sign of the second number. Negative 2x minus 15x is the same exact thing as negative 2x plus negative 15. And so this simplifies down into the exact same thing that we started with. 3x squared minus 17x plus 10. So this would be our factored form. If they asked us to solve, we have two products set equal to 0, so we can use the principle of zero products. That tells us that whenever we have two numbers multiplying into each other or by each other, and the result is 0, you can set each of those factors equal to 0 and solve. So we have x minus 5 is equal to 0, and we could say that 3x minus 2 is equal to 0. So we know in this situation, x would have to be equal to positive 5, or x would have to be equal to 2/3. So I didn't ask you to solve here, but I'm just showing you for your own information that because you have a set of products, meaning values that you're multiplying into each other and they equal 0, the principle of zero products says that we can set each of those equal to 0 and solve independently. If you have any questions, then let me know. Otherwise, I'll give you 4 minutes. Please look at the next question and then we'll review. Okay, so this problem is 14x squared minus 23x plus 3 is equal to 0. So a here is equal to 14. A times c would be equal to 14 times 3. Now that might be hard to do in your head. I'm going to show you a little mental math trick. So if I think of this as 3 times 14, take the more complicated value and split it up into its tens and ones. So think about this instead of 3 times 14, think about this as 3 times 10 plus 4. Right? 10 plus 4 is 14. And then distribute. So 3 times 10 is 30. 3 times 4 is 12. 30 plus 12 is 42. So we're looking for factors of 42. So we're going to have 1 and 42. We're going to have 2 and 26. We're going to have 3 and, let's see, what's 42 divided by 3 is 14. 3 and 14, not 4, and 6 and 7. Notice that 6 and 7 are consecutive, and we need to, so we know that we've exhausted all of the values. I'm sorry, it's not 2 times 26, 2 times 21. My apologies. Doesn't make sense, right? So 2 times 21, or 2 plus 21 is 23. We need both of them to be negative. And then, so A is 14, so I know I'm using 2 and 21. The factors of 14 are 1 and 14, 2 and 7. So notice that 2 and 7 work with 2 and 21. So I'm going to go ahead and assign the right positions as 2x and 7x. And now I want 21 to be associated with 7. So I'm going to put 21 where it's going to be multiplied by 7, and I have to massage it a little bit. I have to divide by the number it's ultimately going to be increased by, the scalar that it's ultimately going to be increased by, which is that other 7, that coefficient of 7 in the inner terms. And then I'm going to put 2 to associate it with 2, but I have to reduce it by 2 because it's going to be multiplied by 2. And again, I want both of these values to be negative in order to add back up to a total negative sum of 23. 21 divided by 7 is 3, so this is going to turn into 2x minus 3. And 2 divided by 2 is 1, so then we're going to have 7x minus 1. If we wanted to check, we would have 2x times 7x plus 2x times negative 1 plus negative 3 times 7x plus negative 3 times negative 1. 2x times 7x is 14x squared. 2x times negative 1 is a negative 2x. 3x times 7, negative 3 times 7x is a negative 21x. And negative 3 times negative 1 is a positive 3. Negative 2x minus 21x is the same thing if we do leave, change, change. Leave the first sign alone, change the operator, change the sign of the second value. Negative 2x minus 21x is the same thing as negative 2x plus a negative 21x, which would be a negative 23x. So our final answer goes back, our factors multiply out into our original form, which was 14x squared minus 23x plus 3. So we know that we did this correctly because our foiling process gave us back what we started with. And so this would be the factored form. And if we were asked to solve, then 2x minus 3 is equal to 0. So 2x is equal to 3, and so x would have to be equal to 3/2, or 1.5. And then also we could set 7x minus 1 to be equal to 0. So 7x would be equal to 1, so x would also have to be equal to 1/7. I didn't ask you to solve, but I'm just giving you that information. If you have any questions, then please let me know. Let's try one more. So let's look at 9x squared plus 27x plus 14 is equal to 0. I'll give you 4 minutes and then we'll review. Okay, so let's look at this guy. So our a value here is 9. It's 9. We have 9x squared plus 27x plus 14 is equal to 0. So a is equal to 9. A times c would be equal to 9 times 14. So again, let's think of that, instead of 9 times 14, let's change that into 9 times 10 plus 4. So 9 times 10 is 90. 9 times 4 is 36. 90 plus 36 is 126. and that's a large number. So let's start with 1 and 126. So let's start with 126 divided by 2, we get 63. Now a divisibility rule that's handy, if you sum up the digits of a number and the sum is divisible by either 3 or 9, that number is also divisible by 3 or 9. So 126, notice 1 plus 2 is 3, 3 plus 6 is 9. 9 is divisible by 3 and 9. So I know that 126 is divisible by 3 and 9. 126 divided by 3, is 42. Let's check 126 divided by 4. That doesn't work. 126 divided by 5 wouldn't work because only numbers ending in 5 or 0 are divisible by 5. 126 divided by 6 is 21. Notice how we're getting closer and closer to filling in that gap between the factors. 126 divided by 7 is 18. 126 divided by 8 doesn't work. 126 divided by 9 is 14. 126 divided by 10 wouldn't work because only numbers ending in 0 with a ones digit of 0 would be divisible by 10. 126 divided by 11, that doesn't work. 126 divided by 12, that doesn't work. 126 divided by 13, that doesn't work. So I've checked all the numbers in between 9 and 14, so I know this is an exhaustive list of factors. I'm looking for two values that add or subtract together to get 27. So let's see here. Looks like 6 and 21. And the factors of 9 are 1 and 9, 3 and 3. So I'm using 6 and 21. 6 and 21 are both divisible by 3. Notice that 6 nor 21 work with 9. So I know that I'm not going to be using this first set of factors. I have to be using 3 and 3 and 6 and 21. So I'm going to start by just splitting up the 3x in the first positions. And now I want, it doesn't matter where I put the positions, where I put the values, because they're both going to be affected by the same value, 3x. So I'm just going to put 21 here, and I'm going to put 6 here, but it really doesn't matter because, again, they're both 3x. But because they're being multiplied by 3x now, I have to divide each of these guys by 3. And ultimately, I want that to have a positive sum, and the c value is positive, so that means that both of them have to be either positive or negative. So I want them both to be positive. So my final answer here is going to be 3x plus 7 times 3x plus 2. And if we were to FOIL, we would find that this works out to our original value. We would get 3x times 3x, first times first, plus outer times outer, 3x times 2, plus inner times inner, 7 times 3x, plus last times last, 7 times 2. 3x times 3x is 9x squared. 3x times 2x is 6x. 7x times 3x is 21x, and 7 times 2 is 14. So, and notice that 6x plus 21x is indeed 27x. So we get back 9x squared plus 27x plus 14, which is exactly the same thing that we started with. So this guy is our factored form. And if we were asked to solve, then we would just set each individual factor equal to 0 and solve. So we'd have 3x plus 7 is equal to 0. So 3x would be equal to negative 7. And so x would be equal to negative 7/3. Or 3x plus 2 is equal to 0. So 3x would be equal to negative 2. So x would be equal to negative 2/3. Again, I didn't ask you to solve, but I just wanted to share that for your information. At some point, we will be evaluating quadratic factors for their numeric value. But for now, if you have any questions, then please let me know. You can either use the live chat function or you can drop a comment below. If these videos are helpful, then please like my stream and subscribe to my channel. I appreciate it very much. But otherwise, I hope you guys have a wonderful weekend, and I will talk to you all next week. Tater Tot, Dr. Tot, would you like to say goodbye to everybody? You've earned a cookie. It's the last class for the day. You were very good. Let's say goodbye. Come on. Can you say goodbye? You say goodbye to everybody? Come on. You can do it better than that. All right. Thank you guys very much for watching. Have a great weekend. I'll talk to you next week.